Morning, everyone. Welcome to the August call. I'm Drew Decker with the National Geospatial Program User Engagement Group. I'll be assisting with today's call. Alex Jonesy with the NGP Topographic Data Services Group is also assisting with the call today. In a few moments, we will begin today's topic, which will be towards an Internet of Water, creating a community search index for water data, and we will be presented by Dr. Kyle Onda, who's Director of the Internet of Water with the Center for Geospatial Solutions at the Lincoln Institute of Land Policy. And Kyle, I see you're on the call, so welcome. And we'll get started with your presentation in just a moment. Before we get started, I always point out that we have the USGS Hydrography Program leads on the call, Steve H.L. Subuto, Sylvia Terziati. I believe they're on the call today, and if you have any announcements you want to provide now, we can certainly do that. Otherwise, what we'll do is bring up announcements from the group, which means everyone on the call as well as the leads, after the presentation and the questions and answers. Anything to bring up now? If not, I think we can go ahead and get started. Kyle, if you'd like to share the screen, we can make sure that it's visible to everybody and go from there. Okay.
Yeah, get the presentation started. Here we go.
Okay. Yes, we see it in presentation mode. Looks great. And what we'll do is we'll take questions and answers after the presentation, unless, of course, you want to cover those as they come up. So either way, Alex and I will help with any questions in covering the chat and taking care of that as it comes up. So again, thank you very much, Kyle, for being here today. I know you gave this presentation, I believe, last week with the NISGIC call, and that was very good. I was on there, so thank you again so much for being able to present it to our group. So please take it away.
Okay, great. Thank you again for that nice intro. Nice to be with you all. So today I'll be talking about the Internet of Water at a couple of different levels, and really delving most into this concept called Geoconnex, and somewhat with how it relates to 3DHP. So why the Internet of Water? There's basically, we exist on the internet a lot, and water data included, and an increasing number of web applications are providing open data. But when you use kind of normal search engines, if you pretend that you don't know who the major water data providers are, it's sort of hard to find things for a particular place or topic of interest in a very structured way. And we kind of accept this because, we know about the federal agencies, we know about USGS and NOAA, and maybe for local to an area, we know about the local agencies. But, if we think about more commercial type information, you can find it very easily and in a highly structured way, quickly on the internet. From movie times to the weather to, you can search for recipes by ingredient and get a pretty good list of things. And so we want water data to sort of be able to do the same thing, right? We want water data to be similarly structured by topic, by space, by contributing organization, and we don't want to require expert knowledge just to even understand who is collecting water data about what and where. So how do we get there? So the Internet of Water sort of began at the Aspen Institute Dialogue series, which created a document called the Internet of Water Report, which pitched this vision of a modern water data infrastructure, where all these different people collecting water data could publish it online so that it's discoverable, accessible, and interoperable. Down the line, a formal coalition of organizations and public agency liaisons at the federal and state level are providing kind of governance over this vision, and so over different organizations that provide technology, research, development, and also socialization amongst water data providers and data users. There's 5 main sort of organizations on the steering committee. These include Duke University, the Western States Water Council, the Water Data Collaborative, which is a community science organization or an umbrella organization of many, CUASI, the Consortium of Universities for the Advancement of Hydrologic Science, and then my shop, the Center for Geospatial Solutions at the Lincoln Institute of Land Policy. We at Lincoln do most of the technology research and development on some core infrastructure pieces. So in addition to the steering committee, there's the wider community of practice and federal and state agencies and community science groups that are implementing the ideas we're putting forward in this Internet of Water Coalition, among which is Geoconnex.us. So in terms of 3DHP specifically, and the Internet of Water more generally, the key goals we're looking at are looking for key infrastructure and tools that allow data providers to unambiguously link their data to a common hydrography and publish metadata about that data on the web. That common hydrography now, hopefully being 3DHP. And then allow for data users to query quickly for hydrologically relevant data sets across all organizations that do so, hopefully at one point of search. So to illustrate kind of what we want to go for, right, you can imagine someone who's interested in a location here and say they want all hydrologically relevant data from the past 30 days for a number of parameters. I have up here precipitation, diversions, flow and stage, and groundwater pumping. So one way we could do that is we could use this network link data index, which is already a service that USGS operates that's based on NHC Plus version 2, to query up and downstream. In this particular query, I'm querying upstream the server a distance of 100 kilometers plus its tributaries, but not all the way up to Snake River, and then downstream to the ocean. And I'm finding data that's linked to the hydrography. In the red, I have some diversion sites that I'm interested in my question from this water data provider, the Western States Water Council. And that might provide me some data. And then we'd like you to be able to go to a knowledge graph that covers more semantic queries. So you can ask for data sets about different variables and then get to the data wherever it might live, whether it's a federal or state agency or a non-governmental organization. So at the Internet of Water Coalition, we have biannual coalition-wide meetings to discuss governance and strategic direction. And then we have working groups that meet somewhat more frequently to kind of advance learning and help me as the director of the Internet of Water Project at Lincoln help me think about where to go and what to do more of or less of or better of. So 2 of the more active working groups are public agencies, which discuss things like procuring funding for IT to do this kind of thing, the kind of messaging that works with their management, the kinds of funding opportunities that are available for them. And then a Geoconnex working group, and again, I'll get into Geoconnex momentarily, that focuses on kind of metadata standard, developing use cases, and setting priorities for software and data development. Moving on to Geoconnex. So this is a standards-based framework to publish and discover water data. A better title would be search engine optimization for water data. Basically, we want people to publish their water data on the internet in a way that lets us build kind of this web of information similar to what underlies the search engines like Google and Bing. But this will allow us the ability to answer innumerable water-related questions. So to get into the framework a little less abstractly, but still very abstractly, right? We want to be able to understand at a very high degree of geospatial specificity what data is out there and how those data sets are related to each other in terms of the hydrology, right? So in a typical cartoon system here, we imagine there might be a dam and a river that flows into the dam. And the Army Corps might be publishing data that it observes or models about the operations of the dam or the reservoir. And a state agency might have a stream gauge or a water quality station on the stream. And so these real world features are hydrologically related. But how can we know? And the hydrology can obviously get much more complex because there's more upstream and downstream relationships. There's surface groundwater interactions. How do we get to all of this data without knowing about it ahead of time? Right. And so how can we enable computers to leverage relationships in the real world that are hydrologic to let us draw connections between data? All right, so the approach we're taking is basically the same way the commercial internet has done it. And certain academic fields have done this to varying degrees as well. But the first requirement is that all sites, specific locations, and environmental features should have universal persistent identifiers, hopefully in the form of URLs. So this is similar to like the URL versions of the DOI and the ORCID systems that identify, academic documents and people respectively. We imagine this kind of thing for real world hydrologic objects. These URLs should point to landing pages, so websites or web pages about each feature. And so here's where we come into the first issue, especially with hydrologic features like rivers and lakes. The permanent identifiers that we have out there are ambiguous and difficult to parse, especially for people, the kind of people who are just making web apps. Right? If we think about this, right? If someone has a column in their data set for a reach ID or a segment ID, it's not clear what version of the hydrography product is being referenced necessarily. The way these are formatted are extremely difficult for people not in the know how to parse. Like, who knows that this is a leading zero that often gets dropped from Excel when you open it, or gets interpreted as a date, right? And it doesn't really, depending on how people are putting their data in their systems, it's not clear which ones are hydrologically related to which, unless you download the entire NHD and all its documentation ahead of time. So what we want to have are persistently identifiable community reference features that have these kinds of URLs that are unambiguous and also self-describing in a sense. So to get at the ambiguity, right, we know in the US there's two major rivers that are called the Colorado River that folks may not know about. So we want them to have their own unique identifiers in the form of URLs. Then importantly, if you were to go to one, I'm going to click on one over here, that resolves to a website that's actually about that river, right? And that's very helpful. And importantly, it has machine readable it has a machine readable version that can be ingested readily if you're going to that URL using a programming language. So the other kind of detour I'm going to take here has to do with the future of 3D-HP, and that's they're going to be implementing this main stems concept. So a main stem basically defines a flow path via its headwater and its outlet. And this is sort of just a different way to cut up the network. That the most important feature is it's fairly constant and interoperable across data sets after a certain resolution, right? So a main stem identified in this way, while its exact geometry might be different, the basic concept of it, if we're talking about indexing things like dams and stream gauges to a segment of the network, will be pretty constant across, even NHD plus, or sorry, NHD version 2 through NHDHR, and then 3D-HP as it iterates moving forward. To give you an example, to give you just a basic idea, on the left, I have the NHDHR, or sorry, I have the NHD plus kind of segments coming down from a point up here all the way down to when the continuous water body flows into the ocean. And I'm pretending I'm an organization that's publishing data about 4 stations along it here. And so the first thing is you'll notice this, the networks can be cut differently. So we have all these segments, and instead the network becomes drastically simplified if you use the main stems concept from, probably several 100,000 or tens of thousands at least of segments to 1, 2, 3, 4, 5, headwaters and outlets that flow into each other. Oops. Excuse me. So to make it a little more concrete, imagine I have this data set where I have some station IDs and some NHD plus, common identifiers associated with them. And then 3D-HP in its current version has some identifier that they're indexed to. And then we also can have the main stem, which is just, this one is on the San Jose River. This one is on the Rio Puerco, which goes up like this, but it meets it. But Rio San Jose is a tributary of the Rio Puerco. And then, onto the Rio Grande with these two. And so the nice thing is as 3D-HP kind of iterates rapidly and its identifiers are not permanent and its specific geometry might change over time, there will be a consistent mapping of the new identifiers to main stems. Which means, so that will be consistent. And it also means since there will be a consistent mapping of 3D-HP IDs to main stems, there's a consistency there moving forward. If folks wish to map or index data to main stems in addition to the most current version of the hydrography data. And finally, to bring it back to ours, coming with the persistent identifiers, right? These won't just be named, but they'll be very clear and unambiguous in the data because USGS will be minting identifiers for the 3D-HP versions of main stems. So there will be an identifier that looks like geoconnex.us / in this case USGS / main stems and some numbers that will take you to a web page and structured metadata about that main stem. We at Geoconnex.us will maintain kind of an API to search for these main stems. This works right now for folks that are technically minded. If you go to this URL, reference.geoconnex.us / collection / main stems, you'll see all the main stems there. And then you can filter by the name _ at outlet. Here I'm putting in Puerco. And there you'll see all of the main stems that have the name Puerco in them. and some data about them. And so there's two Rio Puercos, there's the Puerco River, there's the South Fork of the Puerco River. You can download this directly as GeoJSON, or just browse it like here in the browser and take a look at where that takes you specifically to find a specific one that you might be looking for. And they have this URI tag, which is a URL, which directs you to this back to this web page, and so can be used elsewhere. Skip that one. So it's very useful to have this because that means you can incorporate these identifiers in web apps in addition to data sets. So this was implemented at the USGS Sensor Things API endpoint, which is sort of the next generation instantaneous value service. So this shows a query from USGS for current discharge along each of the two Colorado rivers. So that's just one query for both of them to get the current discharge reading, which I think is pretty cool. You can go see the code to doing that at this short link. So http t.ly/e capital X1 small x. That takes you to the GitHub gist, which is how to do that query and visualize it in R if people want to play with that. But that's querying by main stem. All right, so moving on, right? So what is at these websites that have persistent IDs pointing to them? There's structured metadata that uses consistent ontologies to map whatever attribute names might be in source information and source IT systems to standardized names across the internet. And we use those to describe our real world features of interest, as well as the data sets that are actually about those features of interest. So that's where we're going here. So in addition to the 3DHP, we imagine organizations can have persistent identifiers for their places that they have water data about. That could be, that could be a real-time sensor like a stream gauge. It could be a sampling station. It could be a piece of infrastructure. It could be more like a reporting area, like a district area, some polygon. But the point is those should have each one of those should have their own web page. And in that web page, I have here, for those web developers in the room, it's just embedding JSON LD in the header scripts of the HTML, which conveys sort of descriptive information about the feature in a standardized way. So here in this one, it's saying something like, I am my identifier, my name is St. John River at 9 Mile Bridge, I'm a monitoring location, I have data about gauge height and discharge available at these URLs, and I'm located at this latitude and longitude, and I'm on this main stem. That's the kind of information that would be there. And so if you imagine many organizations doing this, right? So USGS doing it up top, talking about a gauge, and then a state agency doing something similar, right? You can sort of start to crawl through these resources and assemble them into a search index. So how are we going to do this? So the Geoconnex project, I'll start here. Starts with the data user community who we engage with, that we want them to use our search index, which I'll point out is currently, its development is currently supported by a mix of philanthropy and USGS money, and all the data products, all the code and data associated are in the public domain. Anyway, we talk to the data user community, and that influences authoring guidance, or you might call it metadata standards, basically the structured data we want to see in those web pages, which can then be used by data publishers, which enables us to go out and get all that structured information and present it in a consistent way to the data user community. So we also operate our own permanent identifier service. So we don't use DOI.org or anything like that. That's very expensive. So we operate our own, which is free to use. So people are free to kind of create namespaces and submit and mint PIDs. We do moderate it. It's not just automatically approved. We don't want people putting in garbage and vandalism, but in general, if you're an official government organization and your persistent identifiers point to real web pages, we will let it in. And this also has a nice side benefit to organizations, which is that organizations often update their IT systems, they update their URL patterns, and so it can be nice to have a URL that can redirect to whatever the active page is. And so this actually happened where when USGS updated the default NWIS pages for their monitoring locations, and they changed their URL pattern too. So this URL could be consistent, and you could use it in, you can use it in websites or documents where you're referencing pages. It's my mistake. This shouldn't change from slide to slide. There should still be an S there. The idea is they just need to go to the registry and change the redirect. Okay, we're also developing tooling to help data publishers publish this structured data. So we contribute heavily to this open source geospatial server called PyGeo API, which already on the fly transforms data coming from every geospatial data file type to a variety of OGC API standards. So it can be a static file, it can be an Esri feature service, it can be other custom APIs. The software is open source, so it can be extended. And in addition to putting it out in OGC standard APIs, it makes these HTML pages, and we've implemented JSON LD templates to let people publish structured metadata in the way they would need to participate in Geoconnex. Another exciting use case that's come up is right, the whole point is we want people to use common identifiers for reference features to tag their data sets with too. And so the Kawazi HydroShare platform has implemented this. For those who don't know, HydroShare is sort of a content management system similar to a data.gov, where you can, or USGS's science-based platform, but it's open to the public. But in any case, people can go upload data, fill out a metadata form to make sure it's well described, mint a DOI for it, things like that. And a new feature they have is they call our API so that you can tag data with the specific features it's about. So in this data set, I'm tagging the data with several dams and aquatic barriers that data set is about, which is nice because then that data set will show up both in Geoconnex, and actually it uses the correct metadata to show up in Google dataset search. So if enough people start doing that, you can get interesting connections between data sets. So we are indexing the data. I won't get too heavy into that, but there's a whole IT infrastructure we operate to go and harvest the data, make sure the most up-to-date versions are being stored, and making them available via API. And we're working on graphical user interfaces. There is an Esri web map that's on the front for everything we currently have in Geoconnex. It's just a simple web app browser that lets you turn off on and off layers and zoom in and things like that. But it gives you a flavor for what we've got going on so far. So that's at geoconnex.us/IOW/map. I have a lot of reading here, which I'll leave on the screen for now, but I can just take questions now.
Well, thank you, Kyle, very much. Again, for the presentation. Good spot here to show on the further reading. We'll have this in the recording, so everyone will see the links here. And thank you again, Kyle. And we'll begin to wrap up. Any announcements? I'd like to call a group out. Any announcements on hydro from our program folks to the data users? Anyone on the call have any announcements? And if not, what I will say is we're going to be having our next call in September, 4th Tuesday of the month, which I believe is the 26th. So we'll be sending out some announcements very soon. First with the links to the recording for today's call, and we'll provide that to everybody here on the call and on the list, and also following up after that with an announcement with the title and pertinent information on the September call. So, no further ado, thank you all very much for your time today, and if you have any questions on anything, please let us know, and we will see you again in a month.